So we will be seeing this question: generate binary strings without consecutive ones. The question states that you will be given an integer n and you have to return all the combinations. The examples are given here: n equals to 3. So you have to return the first combination, the second one, third one, fourth one, and fifth one. So let's see how to solve this question. So to generate the binary strings without consecutive ones, an n would be given to us. If n is 3, so this should be our output. Now, the binary strings, the combination how to do that: if n is 3, we have three position: position 1, position 2, and position 3. Okay, so at position 1, you can place either 0 or either 1. You can place at position 2 either 0 or either 1. In this third place, the same way, we can place either 0 or 1. But the condition is, if you have placed at the first index, let's say 0, and the second index as 1, the third index you cannot place 1, because that will make consecutive ones. This will have two consecutive ones. That is, they will be side by side, two ones. So that's why we can't add in this way. Another example would be, if I add 1 at the beginning, and then if I add another one, the second position, and third position, if I add 0, then this would also be wrong. We should be careful about the consecutive ones should not appear. So let's think how to solve this question. Okay, so as you have understood the question, that we have to give the binary strings without consecutive ones. So how to solve this? If I tell you to give me n equals to 3, the binary strings, I don't have any condition that there should be no consecutive ones. In that way, if we solve, then it's very easy for us to return the condition that is given in the question. So let's solve the easier. Okay, so let's solve. If we don't have any conditions, let's say, we can either place 0 or 1, we can either place 0 or 1, we can either place 0 or 1. In that situation, how can we do that? Yes, we can use recursion to get the desired output. In that case, if we don't have any constraint, we will have 8 permutations. That is, if n is R3, then the number of permutations is 2 raised to n. That is 2 raised to 3. We will get 8. Now let us have a recursion tree diagram for this problem, that we can have any numbers like 0 or 1. If we can solve this, the major problem that we have in the question, we can easily solve that as well. So let's solve this one. So we would be drawing here the recursion tree. At the beginning, to the recursion function, we would be sending an empty string, that is s, and the another argument that would be sending is, we would be sending with it n. That is how many length of the string we need to do. So at the beginning, the function we have called, in that we will discuss the base cases. That is, if my string length becomes n, then I will return. If not, I will continue my recursion calls. So for each function, I would make two recursion calls. So if I make for this one two recursion calls, then my first recursion call would be to add 0. The second call would be to add 1. So here what I will do, I would add 0 in the first call, and my n is 3 that I will be sending. Okay. So as we know, the left recursion call, it finishes its task first, then it would go to the right side. Okay. So let's continue. Then this recursion call would further call two more recursions. That is, it would tell to add 0 and add 1. If we add 0, then this will become two zeros. The length is 3, the constant thing. And this recursion will further call two more recursions to add 0 here and to add 1. So if we add, it becomes 0, 0, 0. Here it will become 0, 0, 1. Here we have hit piece condition, that is, we have got our string length as 3 and our n is 3. So we would return here. We would add this answer in a data structure and then we would return from here. In the same way, we have got this answer. So we would complete all the other recursion calls and then we would see the output. So here we would go, we would backtrack from here, back and then back. Then we have come till here. The left recursion call is completed. So we go to the right recursion call. The right recursion call, we have 0. We would add 0, 1. It becomes 0, 1. Our length is same. Then this function would call two more recursions to add 0 as well as to add 1. So if we add 0 over here, it becomes 0, 1, 0. We have got another answer. And then this recursion call, it would add me 0, 1, 1. Here we have got the another output. So we have got the output, so we return from here back. So we return here, then we go back, then we go back. So we have now reached the root. So we have got the left answer. Now it would give us the right side. So the recursion call for this right side, the string was empty initially. So we would add 1 in it. So my string would become 1. And as it is, this would further call two recursion calls to add 0 as well as 1. If we add 0, then it becomes 1, 0 and n as it is. And this would add 1, 1 and my n is 3, that is as it is. Okay, so this function would further call two more recursion to add 0 and 1. Are you understanding? So let's continue. So 1, 0, will add 0. So this would become 100 and n as it is our parameter. So this way we have got another output. We would return back. It would go to the left side, right side. Then 101 we have got, and n as it is, we have got another answer. So we would backtrack then. We would backtrack. Now it is here, it's coming here, the last two recursion calls. So it is 1, 1. It will tell to add 0 and it would tell to add 1. If we add 0, then this becomes 1, 1, 0 and our n is as it is. And it would backtrack now because the answer has come. Then the last result is 1, it was 1, 1. So if we add 1, it would be 1, 1, 1 and n. This way, we have got the answers for our recursion call. That is, the case here is we don't have any constraints. So we have got 8 outputs as you can see here. Now it's very easy and simple for us to get the required answer that was mentioned in the question. So let's see how to do that. So in this answer, I want you to focus on 3 areas. That is this one and another this output and another this output. What is similarity in here? Here we have two consecutives that we don't want. This output, this three output. If we remove these three outputs, then we have got the answer. So now how to remove these three outputs? Let's check. See, when we were at this level for this tree, we had 0 and 1. So here the next recursion call was 0. So we added 0, 1, 0. Okay. Now for this recursion call, we will check that if the last element that we added, if it is 1, then we would not call this recursion call. If it is 0, then we would call this recursion call. Understanding? In the similar way, here we had two consecutive ones and this is 0. So how did we added here two consecutive ones? Here this it was the function call. It was 1 here and we also wanted to add 1. So that's why it came here double one. So if we would had not called this, then this would not have. To solve this problem, what we will do, we would take a variable naming it as last, so it will track the last element which we added to the string. If the last element, if we added was 0, let's say, so we can easily add 1 because we don't have any problem. If so, we added the last element as 1, we cannot add further 1. If we try to add further 1, we would get two consecutive ones. So that's why we will not call the recursion call. Okay, so I would write the pseudo code of it, how to implement, then I would show how it will get implemented. Okay, so this is my recursion call that I would do to get my desired question output. The question stated that we shouldn't have any consecutive ones. So what I did was I took a string s to store to get my answers in it. Okay, string s, then int last. This is the variable that we will be using to track that the previous, was it 0 or was it 1. Okay, so the last element is a tracking variable. The data structure, it would be a vector or a list, anything. So we would store the string results in this DS data structure. This is a pseudocode. And int n. Int n is the length of this length. Int n is the length. It is the desired string length. Okay. Now we go inside the function. Our base case is this one. That is, if my string size, that is what we had, no, 0000111, this wouldn't happen, 000 or 010. If this length is equals to my n, that is 3, is 3 equals to 3, in that case I would add this string in my data structure and then I would return. This is the base case. Then I would make the left function call. This is the left function call. This would call the same function. I would add in the string 0, then the last element that I added was 0. Why? Because I am adding here 0. If I am adding here 0, then in the answer output, as you have seen here, if I add 0, then the last, for the next function's call, the last element was 0. So that's why the last element here, it is 0. Understandable? So here it is 0. When the data structure as well the same, then n I give it. In the case of the second, the rightmost function call, okay, the right function call that we are giving now, if last was 0, then only I will call the right function call, that is for 1, to add 1. If my last previous is 0, then I would call my function with s string plus I would add 1 in it. This is the right function call. We had the left, this is the right. So we were all the time adding 1 over here, no? So we will add here 1. And then now the last element would be 1. For the further calls, now my last element is 1. So this is 1, the data structure to store, and n as well. So for the bigger question, I would quickly show you the recursion tree. Then we would continue with its implementation. Okay, so this is the recursion tree that I have drawn. So in this, what we are getting to know is the function that we have written, the pseudocode here above, we would pass the string s and the last value. Just for the recursion tree, I have not added your data structure and so if we have added 1 here, the output becomes 0, 1. Okay, it becomes 0, 1. If it is 0, 1, the function is not affecting like our base case that we don't have any two consecutive ones. So it's okay. So we go for the further calls. Now we have two more further calls. This would call two further calls. Now the output is 0, 1, 0 because the left it always takes 0. It tells to add 0. So we have added 0. We have got another answer. Then we backtrack and then we go here. Now is the case. If we have the last element as 1 and we want to add 1, then this would destroy our case. Like we cannot have two consecutive ones as we said. So if we add 1 still to the answer, this would become 0 1 1. So that is not valid. It would not hit our answer. So we will not take this answer as stated here. If we will take that answer only if the last element was 0. If the last element was 1, let's say here at this point, the function wouldn't had gone to this recursive call. Okay, it wouldn't go at this call. It would directly from here go back here, then go back here, then go back here. It would say, and I have completed my left side and I have got three answers. This is my one answer, this is my second answer, and this is my third answer. Okay, so now we would go back with our three answers we have. These are the three answers. Sorry for all these scribbling I have made you to understand. So it's okay, let's go forward. We have three answers. We go back and then the right side. Yeah, are you understanding this? Is it interesting? This is how recursion works. It would complete first the left one, then go for the right one. Okay, so if we go to the right side, the function call would check, is the last was 0? Yeah, it was 0, it was 0. So it would go and call the right side and we would add 1 in it. This function call would run now. If last was 0, then go and add 1. Are you understanding? So if we add in the entry string 1, this would be our empty string 1 and the n as it is. The last is now 1. Okay, the last is now 1. Now this one would further call two recursion calls, that is the left one and the right one. In the left one we will tell, okay, I want 0, left is 0, so add 0 in me. So we would add 0, it becomes 1 0, and we would update the last value as 0 because we have added here 0. So we would update it and then we would go for the next recursion calls. We have the previous as 0, so it would further tell, add me 0, it would become 100, and it would tell me add 101. In this way these two recursion calls will work and we have got further two more answers. Then it would backtrack here and it would try to go in the right direction. In the right direction, if we go, we had 1 here, we would had 1 here, and we would tell, okay, add me 1. This statement would run now. If this statement runs, it would check, is last equals to 0. But the last, what we had added, it was 1. So this wouldn't run, and we have got our 5 answers, that is these 5 answers. Okay, so I will write it down here below. So as you can see, the 0 0 I have written here. This is the 0 0 1. This is I have written 0 0 1, 0 1 0, 0 1 0, 1 0 0. I have written here this answer, this answer. So congratulations, we have got the answer now. Now I would request you to do this recursive call tree, what I have drawn here, the entire thing. Just once try it by yourself. Like you would have fun to do this. This was going right side, then left side, right side. Then we are hitting the base case. Then you would understand furthermore if you do it by yourself. Now we know the pseudocode. Now we know the how does the recursion works. Now I would request you to try by yourself to code it up in your respective languages in which you are okay with. Okay, now I would show you the C++ implementation of this code of this. So guys, as you can see, this is the C++ implementation. What I have done, this is my call. This is my main function that would return the vector of string of answers. It is a vector which would contain all the strings outputs that we had generated. Now I would call an helper function. In that helper function, the parameters are, this is the helper function. So I would call this function. The parameters are int n, that is the size of the string that we had, the function that was told us to do. Then it's the string s. We would store all this, like we will get addition of the string s. The last element, the tracking that we were tracking 0 or 101. This is it. And then the vector of string to store all the string answers. Now this is our base case, what we had decided. If my string s, its size, if it is n, then I would add in my vector s, I would add in my vector, I would push back my string s, then I would return for this call. Then this is my base case. If it hits, then this would do this work. This is the left call. The left call would call by adding 0 to the string and updating the value by 0, the last one, the last element. And this is the right call. As we have discussed, the right call, what it does, if it checks was the last element 0, if you were 0, then only I would call for 1, as we discussed. So it would call s plus 1, adding 1 to the string, updating the tracking variable. Like we are updating the tracking variable, making it to 1, and we are updating it to 1, and the function call that would return as the output. So for n equals to 3, I have written the main function. If for n equals to 3, we would check the output. So this is the output we would be getting. So that was the code that we discussed now. So if you are watching till the end, please like and subscribe my channel. If you have any comments, please write down in the comment section and I would reply to it. Thank you.